All right, in the last part, we're going to look at creating some simple animations from a series of images. I've already downloaded some images and you might recognize these from the tutorial. It's in the third part of the tutorial. And I have a series of images that I just took of myself with my iPhone, kind of looking left to right and top to bottom. There's a simpler version that you can download if you want to follow along. The stick figure sequence will also work fine for the first part. But work through this yourself so you can understand how everything works. And it's actually really fun to create your own images for this example. So what we're going to do is I've uploaded all of those images into my data folder, which I created. And you'll notice that each one is called like 0.png, 1.png, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.png. So there's actually, it only goes up to 14, but there are 15 in total because we start at 0. And the reason that I did it like that is so I can be a bit lazy and create a for loop to actually load these images for me. So rather than typing out all of those file names one by one, I can do it with a for loop. So let me create a variable and I'm going to call it frames. And it's going to be an array. It's going to be a list variable, an array variable that holds all of these individual images. So I'll just declare it as an empty array. And then I'm going to say in the preload function, I'm going to write for let I equals 0, I is less than 15, I equals I plus 1. So we're going to count from 0 up to 14 inclusive, and then load each of these images in one by one. So I'm going to say frames index I equals load some image in and store it in that index. Load image, and then the name of the image is going to relate to I, right? So I is going to start off at 0, and the first image that we want to load in our set of frames is 0.png. So I just have to write I plus .png here. And because I've named those images carefully, it's going to just load each one in one by one. Let's run the sketch before we do anything else and just check that it loads, and it didn't. So what happened? Looks like there was a problem loading your image. Okay, so can you see what the problem is? I've put i.png, but I actually forgot to put on the data, the data folder. So I actually need to type in data / plus I plus png. That's why it's a good idea to always just run that first thing to test the load, the preload function out. So that looks like it's working. Now let's draw these images to the screen. Now I also set the canvas size to be 480 by 480 because that's the size of these images. And what I'm going to do is I'm going to have a global variable, let frame number. It's going to start off at 0, and then each time through the draw loop, I'm just going to increase that number and use that to decide which image to show. So let's just show that first image, frames 0, and we'll show that at position 0, 0. The width and the height is the same as the canvas, so we don't need to do anything else, and we see the first image out of the sequence. Now if I change the 0 to a 1 here, we'll see the next image out of the sequence, and so on. So what we need is a way to automatically change this index each time through the draw loop. And of course we can use this frame number variable to do that. So that frame number starts off at 0. So if we put frame number in and run the sketch, again, we'll see the first image. But here's the advantage of using a variable, we can change it. So frame number equals frame number plus 1. So each time through the draw loop, we're going to increase that frame number. We'll run into a problem, but we'll see all of the images once, but then we'll hit an error. So we get to the end, and frame num is actually larger than the array. So the biggest index in that array is 14. That's the index of the last image in the sequence. And once we get to 15 here, we get this error. So what we want to do is say if frame num is greater than 14, set it back to 0. Frame num equals 0. And now we'll have this image sequence that loops forever and ever. Maybe I should put this on my computer screen when I'm in a Zoom meeting so people think I'm very busy reading emails. They might also need to call an ambulance for me because it looks like I'm suffering somehow. So let's slow it down a little bit. So one thing we can do is rather than adding on 1 here each time, we can add on a smaller number. So it takes longer for frame number to go from 0 all the way up to 1. The problem with that is that for a while, frame number will be like 0.1, 0.2, and that's not an index on our array. So what we would need to do is round that frame number variable down to the nearest whole number. So let's do that. Let's say frame number equals frame number plus 0.1, but then before we use it, let's round it down. So we'll create a temporary variable called index equals, and we can use the floor function that P5 gives us to round that number down. Floor will just round the number down to the largest whole number. We've got an error. Cannot read properties of undefined reading width. So it looks like I created the temporary variable index, but I forgot to use it here. So I need to put in index in my as my index. So you can see now it might be still a little unnatural, but it's not as unnatural as it was before. Moving at a better pace. And we can change that speed. We can make it run really slowly by just making this number really small. Like that. Or we can make it run a bit faster by making the number a bit larger. Anything over 1 doesn't really make sense because then we'll be skipping more than 1 frame each time through the draw loop. So 0.1 I think is pretty good. So that's an example of creating a simple animation just that loops again and again. But one thing we can do is also make our animations interactive in a sense by making them respond to the mouse. So let me show you what I mean with a little sketch. I come in here, I'll just sketch this out on the whiteboard here. Let's imagine that on our canvas we have 3 rows and 5 columns. 1, 2, 3, 4, 5. 1, 2, 3. Okay, we've got 5 columns and 3 rows. And depending on where the mouse is, we can turn that combination of rows and columns into an index for our animation sequence. So like if the mouse is up here, we want to show the face looking up at that position, right? But if the mouse is down in this corner, we could show the face looking down that way towards the mouse, right? So depending on where the mouse is, we can determine where the face is. And that's why I made this sequence so that it's of me looking up to the top, to the middle, to the top right, the middle left, to the middle right, to the bottom left, to the bottom right. So what we're going to do is, if we imagine that this is frame 0 and this is frame 1, frame 2, frame 3, frame 4, frame 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14, we need a way of taking this row and column and turning it into I'll do that in code. It's probably easier for me to work through that in the code than showing how to do that on the sketch. So let's get the mouse position in terms of which row it's, which column it's in and which row it's in. So let a column equals mouse X divided by 5. No. How do I do it? I want to get the column. Oh, my brain. I'm going to go back to the paper and just sort of to the whiteboard and sort of think it through. If this is 480 wide, 480 divided by 5 is 96. So each of these is 96 pixels wide. So if I divide the mouse X by 96, that will tell me how many of these the mouse X is covering, right? So if the mouse X is over here, it's going to be 3 times 96 and a little bit left over. So I can actually use that floor function again. So the column is equal to mouse X divided by 96 and just floor that. And the row equals floor of mouse Y divided by something. And let's figure out what that is. So this is also 480 high. And there are 3 rows. So let's divide it by 3. So 3 into 480. 1 left over, and 6, 160. So each of these is 160. So you can see that it would be a good idea to make the width and height sort of divisible by the number of rows and columns that you want to have. Divided by 160, and we round that down. So we can then take that and change that row and column into an index on our array. So the index is going to be let index equals row times 5 plus column. And let me explain that if I go back. So if we're in column 2, that means we're in index 0, 1, 0, 1, 2. And I'm going to call this first column the 0 column and the first row the 0 row. That will make it easier. So it's basically whatever like frame number I'm in, it's equal to however many rows there are, total rows, plus however many columns there are in that last row. So it's sort of like 5 times the number of rows, and so remembering that this is row number 1. So 5 times 1 plus 2 times the columns. I'm pretty sure that that's the right sort of formula there. And then we don't need to increment the frame number anymore. Right, so, oh, okay, we've got an error. Cannot read properties of undefined. So once again, I've got this out of bounds error. So what would help me here is to actually print out with the console.log the column, the row, and the index. Okay, so yeah. Column 3, row 1, index 53, row 1. Looks to me like what would actually make this a little bit easier to debug is if I just first get the columns and the rows calculated correctly. So rather than loading the image in at this point, I'm actually just going to display the index on the screen. So I'm going to just console.log them so I can kind of follow what's happening as I move my mouse around on the screen. Okay, so as I move across here, my column onto 1, but my index has not changed actually. And also the row has changed there. Row has changed there. That looks about right for the row. Column 1, 2, 3, 4. Column and the row looks about right. I've put in a mistake here. That's a times. It should be a plus. Sorry. Row times column. Row times 5 plus the number of columns. And I think that will work now. Yeah. So you can see that as I move around, the face is moving too. There's actually a bit better explanation of that in the tutorial notes. If you look at this little diagram here, it sort of shows how to think about that and how it's calculated. So yeah, you have a look through that. This wasn't the greatest. This wasn't the greatest demonstration of my programming prowess because I got a little bit muddled up there. But I think it's also, I'm going to leave it as an example video so you can see how, when we run into a problem like that, the process that we might go through to solve it, like just using these console.logs so we can understand what's happening, going back and just reading carefully that line where it ended up that the problem was. Now, what's cool about this example is you can simplify it too. You can make it so it's just based on what the Y position of the mouse is. And rather than using this kind of formula here, you can just say if Y is greater than less than 160, show this one. If it's greater than 160 but less than 320, show this one. And if it's otherwise, show this one. So you can make a simple animation that just goes up and down based on the mouse. I've seen students do quite interesting things with that before. All right, well, that's the last example for this week. Hope you enjoyed and hope you got some ideas out of that.